Is southwestern Japan on edge again after today's major quake? Kyushu Island was rattled by a powerful tremor on July 28th, raising urgent questions. Was this just another local fault rupture, or could it be a prelude to a catastrophic Nankai Trough quake? In the late afternoon, at 4:27 p.m. Japan Standard Time, 7:27 Coordinated Universal Time, sensors detected a very strong earthquake centered in Kumamoto Prefecture on Kyushu. Japanese authorities initially reported the shock as magnitude 7.1 at a shallow depth of about 6 miles or 10 kilometers, while the United States Geological Survey, or USGS, registered it as magnitude 6.8 at a similar depth. The epicenter was extremely close to land, only about 3.1 miles or 5 kilometers east of the city of Uto. Because of its strength and shallowness, a tsunami advisory was issued for the coast of Kumamoto and Miyazaki. The Japan Meteorological Agency warned of waves up to 3.3 feet or 1 meter high, and the Pacific Tsunami Warning Center cautioned that dangerous waves could reach areas within 185 miles or 300 kilometers of the epicenter. In practice, no large tsunami hit the coast. Within minutes, shockwaves were felt far and wide. The United States Geological Survey's PAGER model estimates that about 813,000 people felt very strong shaking, and millions more felt strong to moderate tremors. In the hardest-hit towns of Kumamoto Prefecture, such as Uki, Uto, and near the city of Kumamoto itself, buildings swayed violently. NHK and other media report that at least 50 people were hurt badly enough to need hospital care, and several dozen homes collapsed under the shaking. Many residents spent the night in shelters or temporary housing. Prime Minister Takaichi's office said early assessments found several injuries, power outages, and fires across the region. Streets were cracked and debris strewn after the shocks. Fires were reported in towns such as Uki. In all, around 45,000 households lost electricity, though major utilities scrambled crews to restore power. Thankfully, all nuclear facilities in the area appear to be secure. Kyushu Electric Power confirmed no irregularities at its Sendai or Genkai reactors, and regulators reported no abnormal radiation readings at nearby plants. As a safety measure, public transit was halted. JR Kyushu announced an immediate suspension of all train services, including the high-speed Shinkansen bullet trains that run through Kyushu. Traffic was snarled as highways buckled in places. Meanwhile, the tremors did not end with the first jolt. Less than an hour later, at 5:12 p.m. Japan Standard Time, another strong shock struck nearby, initially reported as magnitude 6.1. Dozens of smaller aftershocks, magnitude 3.3 to 4.5, rattled the region in the interim. In total, authorities say more than 20 aftershocks were felt in the first hour alone. After the initial adrenaline surge, people poured into streets and parks, wary of further quakes. By late evening, many returned home or to shelters once officials lifted the warnings. Importantly, the feared tsunami never materialized. The 3.3-foot or 1 meter tsunami warning issued for coastal Kumamoto and Miyazaki was cancelled about 2 hours after the quake, once sea level gauges showed only minor sloshing, measured in inches and centimetres in harbours. So, while the ground shook fiercely inland, the ocean remained mostly calm. With the all-clear lifted, maritime and coastal activities gradually resumed, and officials shifted full focus to the onshore impacts. Now attention turns to the scientific side. What kind of quake was this exactly? And did it change the odds of Japan's big one? Initial data strongly indicate this was a shallow crustal earthquake within Kyushu, not a deep offshore rupture. The shock occurred a mere 6 miles or 10 kilometers below ground and shows a strike-slip signature, lateral motion, typical of upper plate faults. Crucially, it was far inland, several tens of miles or several tens of kilometers from the nearest trench. Japan's plate tectonics are complicated here. To the south lies the Ryukyu Trench, where the Philippine Sea Plate is subducting beneath the Eurasian Plate, and to the east-south is the Nankai Trough, where the Philippine Sea Plate is diving beneath southwestern Japan. But this quake hit well northwest of those subduction zones, indicating it ruptured a fault in the Eurasian Plate itself. In short, this was not a classic Nankai megathrust event. One likely culprit is the Futagawa-Hinagu fault zone, the same active system that ruptured in the deadly Kumamoto earthquakes of April 2016. That sequence began on April 14, 2016, with a magnitude 6.5 quake on the Hinagu fault, and a day later the moment magnitude 7.0 main shock tore the adjacent Futagawa fault over a distance of about 18.6 miles or 30 kilometers. Those faults run across central Kumamoto Prefecture and were responsible for tens of fatalities and severe destruction 10 years ago. In fact, field surveys showed the 2016 main shock produced long surface ruptures exactly along those mapped fault traces. Seismologists point out that the epicenter of today's quake, near Uto, lies squarely in the same geological zone. Although it is not yet confirmed which fault broke on July 28th, many experts have marked the Futagawa-Hinagu system as the leading candidate, given the location and similarity in depth and magnitude. If the hypothesis holds, this event would simply mark another episode in Kyushu's restless fault zone. Its similarity to 2016 is striking. Both were around magnitude 7, very shallow, and occurred inland in Kumamoto. But the 2016 and 2026 quakes likely broke different segments, unless one is a very late aftershock. Either way, the huge toll of houses damaged back then, thousands were destroyed or rendered uninhabitable, serves as a grim reminder of what even a shallow quake can do in rural Japan. This time, the damage seems much less, with no bridge collapse like the one at Aso in 2016, but still dozens injured and many homes smashed, so the comparisons are inevitable in news coverage. Critically, residents and officials are asking whether today's tremor awoke the Nankai Trough, the megathrust fault off the Pacific coast that has the potential for a catastrophic Tokai-style quake. Fortunately, all indicators so far say no immediate trigger. For one, the epicenter was about 124 miles, or 200 kilometers, northwest of the nearest Nankai rupture segments, in Hyuganada, off Kyushu's east coast, putting it well outside the trench-bound fault plain. A classic Nankai shock would have struck offshore right on the plate boundary. Instead, this was decidedly an onshore crustal break. Geologic surveys of past quakes offer a reassuring pattern. Historical and paleo-earthquake records show that the giant Nankai ruptures, like those in 1707, 1854 and 1944 to 1946, never extended all the way to Kyushu's shoreline. In fact, such great quakes on the trough happen every century or two, and none of the known events in the last 1,400 years were centered as far southwest as Kumamoto. The area of today's Tembla simply has no paleoseismic evidence of having hosted a great megathrust slip. Seismologists have nonetheless checked for subtle stress changes. Even a remote quake can squeeze or unclamp parts of a nearby fault. Preliminary Coulomb stress calculations show this earthquake raised the stress on the southern end of the 1946 Nankai rupture zone by only about 0.01 bar, a nearly negligible amount. Extending the model to the closest edge of the Nankai fault near Kyushu gives a stress bump of about 0.1 bar. To put that in perspective, the threshold often associated with triggering more quakes is on the order of 1 bar or more. As expected, seismograph networks have not recorded any anomalous activity on the Nankai thrust since the main shock. In short, the quake did virtually nothing to ignite the subduction megathrust. On the other hand, the stress shifts on local faults in Kyushu were more significant. Models indicate the Futagawa-Hinagu faults received a modest jolting, on the order of 0.1 bar of stress increase, and within hours 2 small aftershocks around magnitude 3 or 4 occurred in that zone. Offshore thrust faults just south of the epicenter saw a bigger stress uptick, 0.5 to 1.5 bars, consistent with the handful of magnitude 3 to 4 aftershocks that have already struck north and south of the rupture. Indeed, those figures suggest more aftershocks are quite possible along the nearby crustal and splay faults in the days ahead. Scientists note, for example, that a similar pair of magnitude 6 or greater quakes struck this area in 1996, about 6 weeks apart. Whether these remain smaller quakes or grow, the shaking is expected to stay fairly local. Some analysts have gone further, looking at historical patterns. Remarkably, Kyushu's offshore seismic catalogue shows a quasi-regular repeater behaviour. Magnitude 7 shocks appear roughly every 25 to 30 years in the Hyuga-Nada region, 1931, 1961, 1996, and again in 2024. With the Philippine Sea Plate converging at about 1.7 inches or 43 millimeters per year, 3 decades would supply about 4.3 feet or 1.3 meters of slip, roughly what these moment magnitude 7 events have been delivering. In other words, those moderate quakes may simply be chipping away at subduction strain, not letting it build to a giant rupture. That fits the fact that the last Nankai megaquake pair was in 1944 to 1946, about 80 years ago. Statistically, it is due, but only barely within the average 100 to 200-year cycle. Crucially, most experts now say this Kyushu earthquake does not count as evidence of an impending Nankai rupture. In their words, it looks like another Kumamoto event, not a Nankai foreshock. A recent analysis put the chances of this quake heralding a megathrust event at less than 10%, noting that large foreshocks on Nankai historically rarely occur. For example, that study concluded it is highly unlikely, but not impossible, that the magnitude 7.1 shock will prove to be a foreshock for a major megathrust event in the next several days or months. Japanese authorities appear to share that judgment. They did not immediately elevate the Nankai alert status after the July 28th shock, focusing instead on local recovery. Veteran researchers add perspective. As a case in point, Kyoto University seismologist Yamashita Yusuke emphasized after an earlier Kyushu quake in January that it is unlikely to influence the potential for a future Nankai Trough megaquake. Back then, a smaller magnitude, 6.8, struck in almost the same region, causing minor damage, and yet seismic risk assessments were virtually unchanged afterwards. By the same token, today's larger shake, which released far more energy than that January event, is still not seen as a trigger. In fact, Yamashita noted the January quake released only about half the seismic energy of an August 2024 magnitude 7.1 shock in Hyuga-Nada, implying even more earthquakes may need to occur before any great rupture happens. Of course, Japan cannot ignore the Nankai threat. The trough remains a looming danger. Undersea trench quakes there have historically unleashed tsunamis that could devastate Honshu and Shikoku. Current government panels estimate roughly an 80% chance of a magnitude 8 to 9 event on Nankai within the next 3 decades. That figure, largely driven by long-term recurrence statistics, means experts urge constant preparedness, but it does not mean a quake today has shifted that probability. In fact, officials pointedly note that the routine annual recalculation of Nankai risk includes many factors, decades since 1946, plate motions and historical patterns, and is not toggled by one isolated shock. For now, the focus is on Kyushu itself. Emergency crews are treating the injured, restoring power, and inspecting damaged buildings. Geologists are studying aftershock data and waiting for refined fault models to pinpoint the exact rupture plane. Meanwhile, in newsrooms and living rooms, people anxiously pore over weather news charts and Japan Meteorological Agency communiques. One thing seems clear. This quake, while strong, was a local crustal event, terrifying in the moment but not necessarily a harbinger of an immediate Pacific megathrust disaster. That said, Japan's vigilance remains high. The country is no stranger to jolting surprises, and experts will surely keep monitoring every tremor. Today's powerful Kyushu quake may ultimately be remembered as just another Kumamoto quake, or, if something changes, as a warning that the ground beneath Japan is endlessly restless.